Welcome back, everyone. Today we're going to be talking about factoring quadratics using reverse box method. So using reverse box method, this is where we bring in our PST. We have to know our factors. We fill in our box and factor out what we can from the box. So this is where we have expressions that look like ax squared plus bx plus c. And first, we're going to strictly talking about where a is greater than 1. Because when we have a equal to 1, we really don't even have to make our box, and we'll talk about that in the future. So when factoring quadratics, ax squared plus bx plus c, we need to use reverse box method. Our first step is we're going to find our greatest common factor if 1 exists. Now this may not always happen. We may not always have a greatest common factor to take out of our polynomial, so we're not going to cover that specifically in today's video. Second step, we're going to use a, b, and c from our quadratic equation formula to find PST, which stands for product, sum, and two numbers. The two numbers we find in PST help us fill in the box for reverse box method. Then from there, we're going to pull out the factors from the box to find the two binomials. Example 1 is 2x squared plus 5x plus 3. So to find our product, we need a times c. So we're going to look at this 2 for our a and 3 for our c. We have 2 times 3, which equals 6. And then our b, we're just looking at that plus 5. It's our coefficient in front of our x, or our second term. So we have 5. Now we want to find two numbers that when I multiply give me 6, and when I add together give me 5. So a surefire way of doing this, although it can be tedious at times, is listing out all my factors for 6. So I'm looking for two numbers that multiply to give me positive 6 and add to give me 5. So if I list out my factors, we always start with 1. 1 times 6 would give me 6. Then let's go to 2. 2 times 3 would give me 6. And going on to 3, well, we've already got a list of factors with 3, so we don't have to worry about it. So now out of these two sets of numbers, I have to add them together to see which one would give me 5. 1 plus 6 gives me 7. That doesn't work. 2 plus 3 gives me 5. So we've got our two numbers right there, 2 and 3. Now this is where we go to fill in our box. So on the top left here, I'm going to simply put in my first term, that 2x squared. The bottom right, I'm going to put in my last term, my plus 3. Now I'm going to use my two numbers in my variable, so 2 and 3 with x, to fill in the top right and the bottom left. I'm going to put plus 2x plus 3x. And everything, if I were to add up all of these terms inside of this box, it would give me my quadratic that I started out with. So now we're going to go ahead and factor. We're going to factor by column and by rows. So I'm looking for what's the biggest thing I can pull out of each column and each row. I'll give you a hint. We're always going to have in this portion here and this portion here, we're going to pull out our variables, which in this case are x. So I'm kind of reverse engineering my multiplication table. Now let's look at our first column, 2x squared and 3x. Well, I've already pulled out my x. So do I have a greatest common factor between 2 and 3? What's the biggest number I can divide out of both 2 and 3 evenly? Well, unfortunately, it's only going to be 1. I can't take a 2 out of 3. I can't take a 3 out of 2 evenly. Now looking at my next column, I've got 2x and 3. Again, can't take anything out of both of those, so all I can pull out is a 1. Let's look at my top row. 2x squared plus 2x. I already pulled out that x. What can I pull out of both 2 and 2? It's going to be 2. 3x and 3, going to be 3. So my two binomials, when factored, are going to be x plus 1, because I know 1 times x is simply going to give me x, and 2x plus 3. That is my factored solution for the quadratic 2x squared plus 5x plus 3. So let's move on to our next example. Given another example, 5x squared plus 4x minus 12. Now, this may be a little daunting at first, but we're going to use the same processes we did with our first one to solve for our two binomials. So I'm going to look at A and C. 5 times negative 12, it's going to give me negative 60. B is my 4. So I'm looking for two numbers that I multiply together to give me negative 60, and when I add, give me 4. Now with this one, I've got to really pay attention to that negative sign right there, because that means I'm going to have one number that's positive and one number that is negative. Because when I multiply a positive and a negative, or a negative and a positive, it's going to give me a negative for my answer. So again, this part can be a little tedious, but it's going to save you a lot of time and struggle and frustration in the future if you just list out your factors. So always starting with 1. 1 times negative 60 would give me negative 60. Now it can go either way with my negative, so I also want to include negative 1 and positive 60. Go on to 2 and 30. Like that, negative 30. Negative 2, positive 30. 3 and 20. Negative 20. Negative 3, positive 20. 4 and negative 15. Negative 4, positive 15. So we'll continue our factors over here. I would have 5 and negative 12. Negative 5, positive 12. 6, negative 10. Negative 6, and positive 10. Now, those are all my factors because unfortunately 7 doesn't factor into 60, 8 doesn't factor in, neither does 9, and 10 would bring us back to these factors up here. So I'm looking for two numbers. When I add them together, give me positive 4. Well, that one's going to give me negative 59, so I can cross that one out. Probably cross that one out too. And you can kind of save yourself some steps. If I'm looking for a pretty small number, I'm going to have a pretty small difference between my two numbers here. Looking at 2 and negative 30, if I add those together, I would get negative 28. That doesn't work, so that one won't work. 3 negative 20 would give me negative 17. 4 negative 15 would give me negative 11. So we're getting closer. 5 and negative 12 would give me negative 7. Almost there. 6 and negative 10 would give me negative 4, but I'm looking for positive 4. So that one won't work. But if I take negative 6 plus 10, that will give me positive 4. So my two numbers are negative 6, positive 10. Now we're ready to fill in our box. So again, top left is that first term, 5x squared. Bottom right is that last term, negative 12. Then I use my two numbers, negative 6x, positive 10x. And I'm going to factor. Always start with my x's out here. Look at my first column, 5x squared and 10. So I'm looking at 5 and 10. Greatest common factor would be 5. 5 is the biggest number I can divide out of both 5 and 10. Negative 6x, negative 12. Now I'm going to be looking at my leading coefficient here. Notice these are both, this one was positive because I had a positive 5x squared here. Since I have negative 6x, I want to pull out a negative number. Now, greatest common factor between 6 and 12 is going to be 6. Looking at this row, I've got 5x squared minus 6x. Now, since I have this negative here, but this is a positive, my leading coefficient is a positive, it's just going to be positive 1. 10x, negative 12. Greatest thing I can divide out of both 10 and 12 is going to be 2. And since that leading coefficient is a positive 10, it's going to be a positive 2. So we'll scroll down here, and my answer is going to be 5x minus 6 and x plus 2. Notice I have a negative here and a positive here. Our little friend here, when factoring quadratic trends, if in my quadratic expression I have a plus and a plus, I'm going to have a plus and a plus in my binomials. Minus and a plus is going to give me a minus and a minus in my binomials. Plus and a minus, I'm going to have a plus and a minus. Minus and a minus, I'm going to have a minus and a plus. Make sure you're keeping that in mind when I'm factoring out my polynomials. As long as you're keeping your signs straight, though, you shouldn't have to worry too much about my quadratic trends. Now let's finish up with one where a equals 1. When a equals 1, we really just have to find the t in PST, and then we can write our two binomials. I'm going to show you how with this next example. X squared minus 3x minus 10. A times c. Well, in my first expression here, in front of that x squared, I would have a 1. So I'd have 1 times negative 10. 1 times negative 10 gives me negative 10. My sum is still going to be my b. Let's list out my factors. 1, negative 10, negative 1, 10, 2, negative 5, negative 2, 5, 3 doesn't work, 4 doesn't work, 5 would bring us back to our factors up here. So I'm looking to add two numbers to give me a negative 3. 1 plus negative 10 gives me negative 9. That one would give me positive 9. 2 plus negative 5, that would give me negative 3. So I'd have 2 and negative 5. Now I'm going to show you how we can just use those two numbers to fill in our binomials, but let me prove it first with our reverse box, because you can still use your reverse box to find out what your solutions are. So I'd have x squared minus 10, and I'd have plus 2x and minus 5x. Factor everything out, I'd still have an x here, x here. Greatest common factor between 1 and negative 5, that's going to be positive 1. Greatest common factor between positive 2 and negative 10, well, I'm going to lead with my leading coefficient, so I would just have plus 2. Greatest common factor between x squared and plus 2x, well, that's going to be my x. Greatest common factor between negative 5x and negative 10, leading coefficient is negative, so I know I'm going to have a negative out here. And the biggest number I can divide out of both of these terms is just negative 5. I would have x plus 2 times x minus 5. And notice, plus 2 minus 5, well, I had a positive 2 and a negative 5 here. So you're just able to plug those in to our binomials when I have a equals 1 as in my quadratic equation. All right, I hope this video would help. Please make sure you finish the exit problems in the Wiser Me. Hope to see y'all next time.